My name is Mark Menz, and this is my astronomy term project. The Great Red Spot is a giant storm on the southern hemisphere of Jupiter, around 16,000 kilometers wide, which is 1.25 times the diameter of Earth. It rotates like a hurricane counterclockwise at around 644 kilometers per hour. Among all surface features on all of the planets in the solar system, it is easily one of the most distinct and noticeable for its bright color, enormous size, and changing shape. While some aspects of it mimic patterns we are familiar with on Earth, its overall complexion and patterns of change are matters we cannot fully explain or predict. The sheer vastness and distance of the subject poses difficulty, as the smallest detail we are able to observe with the Great Red Spot is approximately the size of Rhode Island, according to a NASA article in 2021 that we will refer to shortly. This creates a technology gap that prevents us from accurately explaining the reason for the storm's specific properties, namely its distinct red color. We do, however, have the means of obtaining this knowledge through continued research of Jupiter's atmosphere. This could allow us to understand our own weather patterns, as well as recognizing features on planets outside of our solar system, helping complete a greater knowledge of the universe. The actual origin of the Great Red Spot is up for debate. Some sources, like page 202 of Astronomy from the Earth to the Universe by J. M. Pasachoff, cite our knowledge of the storm over 350 years ago, which is a reference to possible records of Galileo having seen the Great Red Spot. However, this could not be fully confirmed, as this may have been a sighting of a different object, which is why other sources, like NASA article Jupiter's Great Red Spot, a Swirling Mystery, published in 2015, only date the storm back by 150 years, which is when we know for certain that a German astronomer named Samuel Heinrich Schwab spotted the storm on Jupiter in 1831. NASA acknowledges this conflict when they state that the storm has been swirling wildly over Jupiter's skies for the past 150 years, maybe even much longer than that. On the other hand, there is no evidence to suggest that the Great Red Spot didn't even exist before our first sightings, as telescopes with the ability to observe Jupiter's surface did not exist prior to 400 years ago. Its true origin remains unknown, as the true scale of its age is a mystery. The physical characteristics of the storm change over time, as the data from our first close-up pictures of Jupiter from Voyager 1 and 2 show different data than what recent pictures from NASA depict. According to page 219 of McGraw-Hill Encyclopedia of Astronomy by Parker Pasachoff, written in 1993, the Great Red Spot was 25,000 kilometers wide and 16,000 kilometers long, giving it an oval shape. This data was taken from Voyager 2, which recorded its data in 1979. A 2021 NASA article titled Hubble Shows Winds in Jupiter's Great Red Spot Are Speeding Up implements data taken from the mentioned Hubble Space Telescope, an astronomical observatory sent in 1990 that since has been able to provide pictures and measurements of the cosmos more accurately than ever before. In the NASA article, the Great Red Spot was approximated at 16,000 kilometers wide. What was once the smaller dimension of the storm is now the larger dimension, as it takes a much more circular shape. The storm is around 3/5 the size it once was in 1997, which brings back into question how much and how often it changed shape before our first sightings. The reason for the shrinkage is unknown, as it does not correlate with the rotation speed of the storm, the rotation of Jupiter, or the coloration of the storm. Not only is the storm getting smaller, but it is also spinning faster. From 2000 to 2009, according to the 2021 NASA article, the overall speed of the winds has increased by 2.6 kilometers per hour per Earth year, or 28.5 kilometers per hour faster over the 11-year span. Similar to an Earth hurricane, the eye of the center of the storm is calm, while the outer rings of it are more violent. However, unlike an Earth hurricane, this calm zone in the center is much larger, and the very edge of the storm is up to 400 kilometers per hour faster than the inner circles of the storm. These outer circles have sped up around 8% between 2009 and 2020, which is a much greater rate of change than the inner circles of the storm. Of course, the raw speed of the winds is out of proportion to what we can relate to on Earth because of how much bigger the Great Red Spot, and the entirety of Jupiter for that matter, are compared to Earth. With the average maximum wind speed of a major hurricane being 160 kilometers per hour and the average circumference of a major hurricane being 1,500 kilometers, according to the National Weather Service's National Hurricane Center and Central Pacific Hurricane Center, the average major Earth's hurricane wind rotates around once every 9.375 hours. According to the 1993 data from page 219 of Pasakov's book, the mean rotation period of the red spot between 1831 and 1982 was 9 hours, 55 minutes, 38.2 seconds, with a range variation of 6 seconds. Now, considering this source was written before the data from the Hubble telescope showed how drastically the winds change in the red spot, I would not trust this data from such a large time scale down to the 6th second like what it's telling me to do. However, it does give us the general idea that the rotation speed is relatively similar to an Earth hurricane. So while 120 meters per second winds may sound extremely fast, because it is, this is partially explained by different speed differentials in the storm and by just how big the scale of Jupiter makes everything. Of course, I wouldn't forget about the second word in the storm's description, its unique red color. Going back to Parker Pasakov's book, page 219 describes the phases in which the storm changes color, stating that it was conspicuous and strongly red in 1879 to 82, 1893 to 94, 1903 to 07, 1911, 1914, and so forth, all the way to the present. When not exhibiting its famous color, the spot dulls into a more orangish, pinkish hue, which is more similar to its surrounding atmosphere. Ever since NASA collected more detailed data on Jupiter's atmosphere from the Hubble Space Telescope in 1979, they have been researching which chemicals cause which colors to appear on Jupiter. There is still no solid consensus on this topic on any part of Jupiter. The previously mentioned NASA article from 2015 tells that studies predict Jupiter's upper atmosphere has clouds consisting of ammonia, ammonium hydrosulfide, and water. Still, scientists don't know how or even whether these chemicals react to given colors like those in the Great Red Spot. The process of trying to figure out which chemicals cause which colors is a process of exposing different compounds to conditions that are similar to Jupiter in pressure, temperature, radiation, and light exposure. This may give us an idea of how chemicals could cause the atmosphere to turn red, like the aforementioned ammonium hydrosulfide or phosphorus, as Parker Pasakov estimates. He deducts that the reason that this specific spot of Jupiter has a different coloration could be because the wind currents uproot normally colorless phosphorus that is now being blown up to the surface and exposed to solar radiation. This, however, cannot be confirmed, as the motion of the deeper parts of Jupiter's atmosphere are difficult to view with our current technology. We are, however, able to see that the spot itself consists of an area of uplifted clouds that are 16 kilometers higher than the surrounding atmospheric levels and 10 Celsius colder. This shows that there is indeed an updraft, that the possibility is not impossible, simply unprovable. Studying the origin and the patterns of the Great Red Spot as it relates to Jupiter may be able to help us understand our own weather systems on Earth. It feels backwards that we should have to look at other planets to understand our own, but our knowledge of how and why hurricanes form is still being developed, and this could provide context to how our weather systems function. The 2015 NASA article states, "Jupiter's weather functions under the same physics as Earth," she said, "just millions of miles farther from the Sun, as we were able to confirm with our comparison of the rotation rates of Earth hurricanes and the Great Red Spot." This difference in distance from the Sun, causing temperature and radiation changes, could be the main reason why our hurricanes have no distinct coloration other than white clouds. However, this cannot be confirmed. The more we research different celestial bodies, storms, the more we may find connections between them. This could help us avoid violent weather patterns while traversing planets with rovers or drones. This pattern recognition could then be applied to bodies that are too far away to view in great detail. Looking at as many possible different cases in our solar system could enable us to then apply that knowledge to extrasolar planets. So while we may not be able to view planets outside of our solar system with the same level of detail as we can see Jupiter, and while we certainly will not be sending probes to planets of other solar systems in the near future, we may still be able to picture features of their surfaces through recognition of those same general patterns from our solar system. It would allow us to make a map of the universe without having to be limited by our centuries' technology. While our current technology allows us to measure the physical dynamics of the Great Red Spot, we are not able to confirm conceptual reasons as to why those properties are the way they are. Our data, spanning at least 190 years, maybe even more, while vast in the context of human life, is small compared to the great mystery of this giant storm 778 million kilometers away. Even understanding this great task, researchers predicted, dating back to our first close-up observations in 1979, that by now we would understand the nuances of its chemical composition and why it changes so frequently, but this is yet to be completely understood. We do, however, have the means of gathering this data through the perseverance of agencies like NASA that strive to conduct experiments and improve our technology needed to solve this vast mystery. We can only hope that the storm does not fully disappear before we are able to create these discoveries. A marvel of this grandeur has no equal within our solar system, and it would be to our greatest benefit to extract all knowledge we are able to develop from it, before it may one day leave the face of our night sky.